the SSL HTTPS series today. A talk by Johan and Nils about results for enabling HTTPS. And on the client side, it's quite easy. I change HTTP to HTTPS and everything is done, but I think the tricky things happen on the server side. And this is what this talk is about.
Okay, thank you very much. So Nils and I are software architects. We are developers, essentially. Thomas, on the other hand, who cannot be here, is a cryptographer. Now, in a way, it's quite apt that Thomas isn't here, because our talk today is very much about how you can set up, how you should go about setting up a secure web server without too much access to cryptographers. So we're going to look at the DevOps approach to setting up HTTPS. So what is our starting point? Well, I think that HTTPS is hard to set up and it's hard to maintain. So I think that we should prepare a talk on that for OWASP. Don't you think so, Nils?
When we started this, we thought it would be simple. Just enabling it, actually some time ago. But this year, a lot of problems appeared with HTTPS. To illustrate this, we put a list of known problems with HTTPS on the slide. I'm not going into detail of all of them, but just to illustrate to you that there are a lot of them. Some of them have been mentioned in the previous talk or in the talk just after the break. And one important thing you can observe here is the dates we put there, is the dates when there was an advice to try and prevent it. It's not always the date it has been discovered, sometimes it has been discovered before that as a theoretical attack, but then it was, on these dates it has been considered to be practical, so that we have to do something against it. And you can see in the last year there are 5 more things that appeared to be a problem, where you have to try and configure your server against that. This is not the only problems there are with HTTPS, but these are the ones that you could do some server configuration for. And this is an illustration that setting up HTTPS right is harder than you would expect. And because of a lot of them appeared this year, it's changing faster than we would expect. And this made us realize that we cannot just use SSL anymore. We have to configure it correctly. And the question is, are our operations sufficiently agile to follow on this fast changing pace? To see what the current state is, we look to the SSL Pulse report of the 2nd of August this year. SSL Pulse does a scan of HTTPS servers to see what ciphers they support and what kind of protocol or problems appear. And we put some numbers on the slide to show that there's poor deployment of known mitigations against these problems. I'm gonna take 2 examples. For example, SSL 2.0. who is known to be insecure for several years already. Nearly 1/3 of the servers still supports it. Another example, TLS 1.2, who's the only one who has really secure ciphers. Looking to the table on the previous slide, 5 years after it has been released, more than 80% doesn't support it yet. So this shows that the known mitigations are not always deployed in practice. And this was our motivation to state that we need a systematic approach for this. We need a systematic approach to set up HTTPS correctly that has several properties. It must be repeatable, so not just logging in on the server, changing something by hand and logging out again. No, it must be easy to repeat. It must capture your knowledge and allow for sharing this knowledge. It must allow to agility to react on changing advice if the pace does increase or there's new tips on how to set up. And it must simplify assurance and verification of this. And we found these properties in DevOps. DevOps is a convergence between development and IT operations, where practices of agile development are applied on operations. And one of the key concepts is that you see your IT operations, the setup of the server, you capture it in code. And because it is captured in code, you have a repeatable setup. Everything is captured in code and automated. In recipes, in languages like CF Engine, Puppet, or Chef. These are example languages. We're going to use Puppet in this presentation. It allows for knowledge capturing and sharing because the code you have, or the recipes in these languages, they provide you with an up-to-date documentation how the setup is done. You can build on existing modules that you find on the internet and sharing knowledge. And it provides you with an abstraction because it's in the recipes. Not every sysadmin or developer who uses this needs to know all the details and does have to be a cryptographer. It allows agility to react on changing advice because it shortens your release cycles. Everything is automated. It's very easy to do small changes and release them fast. And it provides you with some assurance and allow for verification because everything is in source control for traceability, and it's very easy to replicate an environment to do testing and verification on. More concrete, in this talk or in the demos a bit further on, we're going to use Puppet. I'm going to try to explain you the basic concepts using an example. The example is I want to set up a server with Nginx, a specific version, 1.4.2, with SSL enables and some specific cipher selection to select some secure ciphers. What do I need to do in Puppet? I want to apply it on a bunch of servers. In Puppet, if you want to describe or set up a server, you describe the desired state you want the server to be in. It's not a script per se, it's not a set of steps to bring it to there, but you describe a desired state, so a declarative description in manifests or recipes. And you do this using resource abstractions. I put 3 examples on the slides. In this example, if the package resource abstraction is used to say this piece of software must be installed on the system. For example, Nginx 1.4.2. The file resource abstraction is used to say, for example, this Nginx configuration file must be present on the system and it must have this content. And the service resource abstraction is used to describe that the service Nginx must be running and must still be running after restart. Let me switch to the actual Puppet file to show you how it more or less looks. The details are not so important, it's just to illustrate how this is described. So the package resource abstraction says there must be an Nginx with a specific version. The version here is a variable, it's filled in somewhere else. A file resource abstraction to state that an Nginx configuration file must be present, that it's constructed the content from a certain template. This is this file. It's just a normal Nginx configuration where certain values are filled in from the Puppet content. And then I have a service resource abstraction that says the Nginx service must be started. This is more or less how you, in a declarative way, describe your server setup. As part of this talk, we're going to demonstrate the stuff we do. So everything we we show here or we talk about, we made examples for, and they are available on the Git repository. I'm going to show the URL a little bit later on, so you can try it out yourself. It's a rather easy setup, so it's easy to experiment with. The first thing I'm going to show you before I do a Puppet run is that Nginx is not available, and that there is no web server running on this machine. Not on HTTP, not on HTTPS. A bit bigger. It's better? I'm going to start running Puppet now. What Puppet will do is it will take my description of the system and compare it with the current state, and if it sees things are different, it will start changing it to bring it in the state I want it to be. I put a Puppet command in a script because it's rather complex to type it in the demo. This takes a while because internet access is slow here, but I can show you what the output is. Because I did it just before the talk, and it will tell you I changed these things to the system. I added an app repository, it's somewhere in my script, it has to be added. For a specific Nginx version, it uses this file resources to ensure that the correct files are on the system. It installs Nginx for a specific version, and it will ensure that the Nginx service is running. I think by now it will have finished. Nearly. If I run it again, so it has the same output. If I run it again, nothing will be changed because the system is already in that state. If I would remove one file or stop something, something would change. And I can show you now that Nginx is indeed running. And if I do a request on HTTPS, it's set up and configured to everything. This is just to demonstrate the basics setup with Puppet. The next topic is how to configure your cipher list, which is going to be done by Johan. No, first the versions.
So let's have a look at the server. Is this on? Can you hear me? So let's have a look at the versions, or rather the machine that Nelis has been interacting with. So we're setting up a mission-critical machine here. My reflex, I don't know about you, would be to try to take a long-term supported version. So in our case, we opted for Ubuntu Server 12.04. One of the reasons, obviously, to take a LTS version is because of the security patches. Now, it turns out that if you do that, there are a number of problems. And the first one is that the packages, the binary packages that are available in official repositories do not support TLS 1.2. So in further talk, it will transpire that that's actually quite important. Then OpenSSL, that is available for Ubuntu, doesn't actually support GCN. Again, it turns out that support for GCN is quite important. If you look at Ruby, then if you go below patch level 247, then it suffers from hostname check bypassing. So what are we to do? Now, being rather simple-minded, we thought we'd compile from source and install. But hang on, doesn't that mean that we've just blown all the warranties, all the supposed benefits of using an LTS version? So I'm not sure that this is the best solution, but then maybe there aren't any good solutions anyway. Interesting topic to talk about later on maybe. Okay, so what I would like to do now is to drill a bit deeper into the configuration of Nginx. As an introduction, I wanted to repeat the list of vulnerabilities that have been in the news recently and point out that the cipher list is going to address a number of these. So Beast is going to be addressed by the cipher list, the correct configuration of a cipher list. Lucky 13, RC4 vulnerabilities, and forward secrecy. Now the other ones, SSL stripping, let me see, crime and breach, Nelis will cover in a later demonstration. So let me get started by showing you what this cipher list actually is. This is tricky. I'm not going to be able to hold this microphone and do the demo. So I hope that people understand me without a microphone. Ah, okay. So how do I fit this? Okay. So let's have a look at the Nginx configuration file. Nginx, Nginx conf. So this is the configuration file. Somewhere there is a cipher list. Here it is. Looks quite cute, right? Until, whoa! Look at that. That's all the cipher list. Now, this goes on and on. So this is turned out to be quite a complex thing. Before I tell you how we built it up, let me just explain what it does. Do I have a mouse here? Okay, here. So a cipher list is actually a concatenation of cipher strings. And a cipher string can be the name of a cipher, like this one here. But it can also be a specification of a cipher list it can designate a cipher list itself. So for example, this one here says all the ciphers that use DES for encryption. And then the cipher strings can be modified. So actually this one says, if you look at the complete string, it says not the ciphers that have been that use DES for encryption. What we have done is we have built up this cipher list modularly. Let me scroll up. We've taken the various vulnerabilities and we have made a separate cipher list that would mitigate for that specific vulnerability. And then we just concatenate here. If we go, sorry. So here is the cipher list. It concatenates all the individual mitigations. And for each mitigation, we've actually tested this. We've used a technique that we borrow from development, that we practice in development too, namely TDD. The idea behind TDD is very simple. You start by writing a failing test, you demonstrate that it fails, you then write some code that fixes the test, you refactor, and you repeat. So demonstrating this for the Beast vulnerabilities, or actually let me first let me first show you the tests in action. So we use RSpec. If we put in format documentation, then we're going to have nice output, and then we run a suite of tests on the cipher list. Okay, so here it goes through the various tests, and at the moment with the vanilla setup, they all pass. Now I'm going to stop them passing by setting the cipher list so that they allow every cipher. So this one here. So I have to run Puppet again. And if I then rerun the tests, surprise, surprise, they fail. Now, what I'm interested in at the moment is working with the beast attack. So I select that test. I go beast, -e beast. And of course, that fails. Now, interestingly, the test actually tells us the bit of cipher list that we have to put in. And we've written our test so that it outputs the strings, the cipher strings that have to be removed. So that's what we do. That's this one. That's this one here. You'll have to take my word for it. It's rather a nuisance that we actually have to enumerate all the ciphers. We do not have a nice, concise expression of what the properties of these ciphers are. Obviously, what all these ciphers have in common is what we say in the tests, namely here. The cipher spec mode has to be CBC, and the protocol version has to be lower than TLS version 1.1. But OpenSSL does not allow you to specify it that cleanly. So the only option that you seem to have is to list all the possible ciphers that are actually vulnerable to that attack. So let me show you that I can actually become protected to the beast attack by selecting a cipher list that appends the impervious to beast string. So next thing I do is I run Puppet again. And lo and behold, we are now safe for against the beast attack. Okay, let's. I could go through all of these, but I'm not going to do that because that would be rather boring. Let me just go back to a situation where we were, to the situation where we were. So that's this one, and then of course, if I run Puppet again, then all our tests will be will be passing again. Now there is a problem with this. and that's namely we now have so few ciphers that are supported that in effect we do not have any ciphers anymore that can that are supported by browsers as well. No browser can actually make use of the resources that are served by our web server. Let me show you. So a little script that we wrote to extract the supported ciphers. Oh damn, that didn't work. Sorry about that. Okay, here goes. So, people at the back of the room won't be able to see this, but so what this says, yeah, but it's too low to. So what this says is that the accepted ciphers are all TLS version 1.2. They all use GCM mode, and none of the browsers actually support any of them. So, you know, our web server has become rather useless. So we sort of thought about that too, and we included tests for compatibility, and if I run those, then indeed it tells me that I've got failing tests, namely it only supports GCM, which we knew, and it doesn't support Firefox and Chrome. And in fact, in this run, we've even disabled the tests for the Microsoft browsers because, you know. What do we have to do in order to regain compatibility? Well, we don't really know. But I mean, the obvious thing is looking very hard at which browsers you have to support, and then to select the least bad one. We thought that, you know, a pretty good guess might be this one. So elliptic curve Diffie-Hellman, ephemeral key exchange with RSA, blah blah blah. It has RC4 as an encryption stream note, but so let's try with that one, so this one has this compatibility string appended to it. And if we now run Puppet again, then our compatibility tests should pass. Okay, so now we have 0 failures. Okay, so I think that Nelis, you're going to cover the order in which the cipher suites are covered or offered, because that's a very important topic too. So let's get back.
Important also is that we now added a cipher suite that is not secure for one of the attacks, the RC4 attack. But we have to add it for compatibility. But the general agreement that we found on the internet is this is the least worst one to add back again. So that's why we added that one.
So I didn't cover that because of a lack of time. I think that this one is yours, isn't it?
Yeah. So next to the cipher suites, we have to do more configuration in Nginx to get everything right. There's 3 more important things to do. Because of the compatibility, we had to add less safe cipher suites. So we have to encourage in connections to use the safe ones first. And there's actually a property in both Apache and Nginx to do that. It's this one. So you prefer the order of the cipher list as given by the server, not by the client. I'm going to put it off just to show the tests. A second important configuration is to prevent SSL stripping, is to add a header, strict transport security, that says to the clients that if they reconnect to the server, they should always use HTTPS connection. In this case, for the next year. It's a typical way of specifying that. You can disable this header. And another one, it's not really a practical fix for breach. I don't know if you heard about it. Breach is a new attack on the Black Hat conference a few weeks ago, attacking the combination of HTTPS and compression in HTTP. So we disabled it, compression. I'll put it on just to show the test. It's not really practical because in practice you can't make that for a high volume site to switch off compression, but there's no practical advice yet on how you should do it then. Switching to the tests. So you see I made 3 tests that are failing now. One to check for two to check for the headers, the strict transport security, the HZIP header, and the one preferring the order of the ciphers. To test this, I with OpenSSL S client, I connected to the server and I changed the order of applying them. And in this case, because I switched it off, it uses the order that is given by the client and not the one that is securely supported. So this is showing how you, with using Puppet, can do a safe configuration of your ciphers, of your Nginx configuration.
So I wanted to give a demo about Vagrant as well, but in the interest of time, I'm going to skip the demo. But I would like to just say that in the course of developing the code, Vagrant turned out to be very useful, turned out to be invaluable actually. It is a very easy, clean way of rolling back a virtual machine that you are installing with your DevOps scripts, and then executing the manifests, in our case the Puppet manifests. What we have also added to the Vagrant run is running the RSpec tests. So when the virtual machine comes up, it kind of self-tests. You see by the end of the by the end of the boot process that the machine is indeed in the state that you want it to be, or rather the way that you have specified it to be in your RSpec tests.
Okay, for conclusions, we're gonna talk about our experiences with this briefly. To sum up, is configuring HTTPS hard? I think we found it very hard. One of the hard things is to get a good cipher list, and specifying the cipher list with OpenSSL in Nginx and Apache, it's the same way how we specify it, is rather fragile. Can give you a few examples of a cipher lists we got from the internet. We put them in our configuration, and then we started testing it, and it didn't do what we expected because there was a typo in it, and then it just falls back to the standard configuration because there's a thing that is not identifiable by Nginx, and then it puts an error in its log, but it just starts up with the standard configuration. This kind of things happen. So it's very fragile, so it's very important to really test it thoroughly. Also, we were not really happy with the solution of having to make our custom web server by building some stuff from source. This is something that stays hard. It's a trade-off between having the latest security patches and having a long-term support version of your operating system. And I think we also showed that you have little chance with one-off manual installation or configuration. Maybe once you will be able to get it right, but a month later there's a new security advice and you have to redo the whole thing. And I think if you do it manually, you have little chance to get it correct always. Did DevOps help us with this? At least in our perspective it did, because it provides a systematic approach to tackle this with the correct properties. And especially it allows us for extensive testing and experimentation by this automation. And I think we try to demonstrate that. You change something, run a Puppet, run a test, and you see if it's still correct. Of course, there are some limitations with what we've shown here and what you'll find on the GitHub repository, because we only focused on getting HTTPS right, not the whole stack of web server setup. We didn't look to the other security properties. We also didn't look to the added risk of adding Puppet to your configuration, because it can be used for remote management of the service. It adds risk too. We didn't look into that. And one important thing is, for testing for these attacks, we didn't directly test for the attacks. We didn't, for example, test if this is if you can do a breach attack on this. This is not what we test. We test on indirect properties of the attack. For example, we know that breach is bad if CBC mode is enabled in TLS below 1.1, and that's where we test for. We test if these ciphers are available. Beast. Yeah. What do we want you to remember from this talk? If you want to systematically set up HTTPS right on your service, you could use DevOps for this, and by coding your infrastructure and doing extensive testing. That was it. We're ready for some questions.
Johan Nelis, thank you very much for this user-friendly introduction to the cipher hell. It's really a mess. If you're looking for a cipher which is supported by most of the browsers, which is not vulnerable against Beast, and you try to avoid RC4, you're in the empty set. Yeah. And we need more browsers supporting TLS 1.2. 0.
Yeah.
Okay. Any questions?
Well, who tells me which ciphers are currently okay? Because I looked at the OpenSSL validation of Police.
SSL labs.
SSL.
Yeah.
And they tell you, okay, you're safe against breach, but in the article about breach, there is this link on RC4, and then you follow this link, and you follow another link, and then everybody adds to this and tells which cipher works, but you never get the full list that is really okay.
Okay, so the question is, who can tell me what ciphers I should use? Our answer is not us. I mean, if Thomas had been here, then you know he would be qualified to speak on that as a cryptographer. We are not cryptographers, but our message is, you know, go and get the best advice possible, and then capture that advice in scripts. Capture that advice in code that will set up your service, rather than you know, redoing it manually.
And if you collect all of the advice, but the problem is there's no little authoritative sources. It's all blog posts. There's a blog post here for this, there's a blog post there for that, and they all give you advice on your cipher selection string, and they are all different. That's why we split our cipher selection string in several parts, in subparts for each of the things, and we made individual tests for them to try and simplify that for us. So we also did all what you described, follow all the links of the blog posts, and made individual cipher substrings for that and added them together. And because we have a cryptographer in our team who made this, we feel a bit confident that it's okay, but that's it. We also run the SSL labs test against it, and it was quite positive. but what else can we do?
Did you do any research into the approach, reason, or timetables of browsers and then and the company finding as to how they can fix this lack of cipher of agreed on ciphers?
We didn't do any systematic. Oh yeah, sorry. So the question was, do we know about timetables in which the major browsers will make the newer, more impenetrable ciphers available? The answer again, I'm afraid, is no. I'm not sure that there are such timetables either. I just have heard anecdotally that Chrome would be supporting TLS 1.2 GCM mode soonish. But I don't know, Niels, do you know any more about it?
I know that for a while the browser said the servers are not supporting it, so why should we support it and the other way around? So that's one of the reasons why it probably is not supported yet. But
maybe I will remark to this topic, at least the Wikipedia article about TLS from last Monday has a nice overview about the supported ciphers in the current browsers and beta versions. I hope they maintain this list carefully and also in the future. Further questions? Yeah.
Why do you select modes and management? Did you look at any other options?
Why did we select Puppet? Because we knew it from other projects, and I've used it in practice in several things already. I know the other options, but I've not used them in practice, so it's not specifically. Our message is not you should use Puppet. Our message is you should use DevOps. I think Chef is also a viable alternative. CF Engine is a little bit older. There's a newer language, Salt, but I think they are all a bit in the same nature.
Yeah, thank you very much. We have now the lunch break and we'll